Good day, lovely people. I hope you are doing well. All right. I'm back again with Molar Volume. This is your tutor Bogan Masango. Don't forget to subscribe, which is free of charge, and remain blessed as you do so. And also like and share. You may comment as well, and also share. Click on the notification button so that you'll be the first to receive the uploads. Okay. Now I want us to look at the Molar Volume. Okay, molar volume, which is where 1 mole of a gas occupies a volume of 22,4 cubic decimeter. Remember, 22,4 cubic decimeter is exactly 22,4 liters. 1 liter is equal to 1 cubic decimeter at standard temperature and pressure at STP. All right, what are the conditions for the reaction to be at STP? The temperature must be 0 degrees Celsius, or it must be 273.15 kelvins, and the pressure must be 1 atmosphere, or 101.325 kilopascals. If you were to convert this kilo, you'll have 101,325 pascals. Okay, we also have a formula that we're going to use here, which says the number of moles equals to volume over molar volume. We know number of moles, SI unit is mole, the volume is cubic decimeter, okay, and the molar volume is cubic decimeter per mole, so it's volume per mole. All right, I want us to look at some examples that we'll be dealing with here so that we don't get lost. Okay, I want you to look at the practice question. Don't worry, I'll be using this because I want to work together with you here. All right. I hope you can see clearly. Okay. Now, practice question. Number 1, it says, consider the following balanced chemical equation. It's 2x, okay, 2 moles of X, which is a solid, react with 6 moles of hydrochloric acid, which is aqueous, and then to give you 2 moles of the product XCl3, which is also aqueous or in aqueous, and then plus 3 moles of hydrogen gas. Okay, during the reaction 0.405 grams of metal X. So we are given the mass of metal X. Okay, react completely with hydrochloric acid. Okay, what does it mean? It means the metal X will be finished. Okay, and while reacting with hydrochloric acid, we normally use the term its limiting reagent. It's the one limiting the reaction, because if it's finished, then the reaction cannot continue any further. Now, with hydrochloric acid solution to produce 504 cubic centimeter hydrogen gas at STP. What is this? This is the volume of hydrogen gas. It's not the molar volume. It's not Vm. It is V, because it's just the volume of hydrogen gas at STP. Okay, and you know definitely at STP, you are going to have what at STP? So it's looking for the number of moles of hydrogen gas is equal to volume of the gas produced over the molar volume. Okay, what is the volume of the gas? It is 504. Please note it's in cubic centimeter, and we are going to divide with the molar volume, that is what? 22,4 cubic decimeter. All right, so we need to convert this 504, okay, from cubic centimeter to cubic decimeter. So our conversion factor is a division. We divide with 1,000. Okay, all right, we divide with 1,000 there to convert from cubic centimeter to cubic decimeter. All right, can I just write it here on the side so that you note it somewhere? Okay, if you're converting from cubic centimeter or milliliter, which 1 cubic centimeter is exactly 1 milliliter, you must divide by 1,000 to change it to cubic decimeter or liters. All right. Note this: 1 cubic centimeter is exactly 1 milliliter, and also 1 liter is exactly 1 cubic decimeter. Okay, so what is our answer going to be? We are going to divide the 544 by 1,000, and then whatever answer you get, which is 0.504, you divide by 22,4. Okay, and my answer is 0.0225 mole. Okay, that's worth 3 marks. Okay, now I've got my number of moles, and now I must look for the molar mass, okay, of metal X. What do I have for metal X, guys? I only have, if we go back here, maybe I should write it here so that we can remember. X solid plus 6 HCl aqueous gives me 2X CL3 aqueous plus 3H2 gas. What am I given for X? I'm given the mass. All right, so I have the mass of metal X. Okay, and then now I'm looking for the molar mass. Okay, if I have the mass and the molar mass, I mean the number of moles, I can get the mass, but I don't have the number of moles of X, but I have the number of moles of hydrogen that will be produced. Now remember, we said this equation is related, or these are reactants and products are related in terms of moles. We say 2 moles of X solid reacts with 6 moles of HCl to give you 2XCl3 aqueous, okay, plus 3 moles of hydrogen gas. Now let's relate the X to the hydrogen gas. Okay, you can see the mole ratio is 2:3. Do we have any moles for the X? No, we are looking for it. Do we have any moles for the hydrogen gas? Yes, we calculated it, 0.0225. Okay, well, you cross multiply. Okay, by now you know that we are looking for moles. X is mole, then you multiply. Okay, then you divide by 3. You're going to get 0.015. Therefore X will be 0.015 mole. What is this one? This is the mole of metal X. Therefore number of moles will be equal to mass over the molar mass of X. That's what we are looking for. We are looking for the molar mass of X. Okay, what is number of moles? It's 0.015. I hope you can still see. Equals to, what is the mass? It's given. Okay, what was the mass actually? It was given, and remember it's the mass is 0.405 grams. Okay, so the mass of X equals to 0.405 grams. Okay, so that you don't forget. And then don't have to put the grams there, sorry. And then we are looking for the molar mass of X. Okay, you can see what we will do here, and therefore your molar mass of X will be equals to 0.405 over 0.015, 27 grams. Molar mass is what in grams per mole. Okay, identify metal X. Okay, 27, that's aluminium. Okay, where's the periodic table? I don't know, but definitely you can check it wherever you are. Identify metal X. Metal X is Al, or aluminium. Okay, that's it, guys. I hope you did grasp something, and we will be doing more and more questions if possible. Thank you so much. I'll be coming back with molar concentration and therefore empirical formula. Remain blessed.